The standard is about sequences. We're going to talk about two different kinds: arithmetic, where you get from term to term by adding, and geometric, where you get from term to term by multiplying. So this first one is arithmetic, because to get from one term to the next, you can see we're adding 4. 6 plus 4 is 10, 10 plus 4 is 14, and so on. The name for the number you're adding each time is the common difference. And that's abbreviated D. So for this sequence, the common difference D is 4. To find the explicit formula for an arithmetic sequence, the general form is a sub n, and that means the nth term, like the 10th term if n equals 10, or the 12th term if n equals 12, equals a sub 1, which is the first term, plus d, the common difference, times n minus 1. So for this example, a sub n equals the first term, which is 6, plus 4 times n minus 1. So if I wanted to find, let's say, the 11th term, a sub 11 would be 6, plus 4 times 11 minus 1, which is 6 plus 4 times 10, 6 plus 40, which is 46. There's another way to think of getting from one term to the next. That's called a recursive formula. The recursive formula just tells you how to get from one term to the next without necessarily specifying what the first term is. So it looks a little confusing, but it's not really saying anything that hard. The nth term is the term just before it, so the n minus 1 term plus d. So say n was 5, the 5th term is the 4th term plus d. For this sequence, a sub n equals a sub n minus 1 plus d, which is 4. So you can use sequences to express some real-life situations. Let's say you start a savings account with $400 and save $15 each month. So we're going to write an explicit formula to represent the amount of money you invest into your savings account. So the first term, A1, equals 400. The second term, A2, is 400 plus 15, which equals 415, and so on. So to write the formula, a sub n equals the first term, which is 400, plus d, 15 each month, times n minus 1. So for the 12th month, a sub 12 equals 400 plus 15 times 12 minus 1, which is 400 plus 15 times 11, which is 565. The other type of sequence we talked about in this class was geometric sequences. So in a geometric sequence, instead of adding the same thing each time, you're multiplying by the same thing each time. In this sequence, we start off with 3. To go from 3 to 12, we multiply by 4. 12 times 4 is 48, and 48 times 4 is 172. So the number that you're multiplying by is called the common ratio, and that's called R. So an explicit formula that would give you any term in the sequence, a sub n is any term you're looking for, is the first term, a sub 1, times this common ratio raised to the n minus 1. So for this sequence, a sub n equals 3, because that's a sub 1, times 4, I should probably write this up here, r equals 4, times 4 to the n minus 1. We can also find a recursive formula for this sequence. So the recursive formula, a sub n equals a sub n minus 1 times r. So this means from any term, to get any term, you take the term before it and you multiply it by r. So if you're looking for the 6th term, n would be 6. The 6th term is the 5th term times r. So for this sequence, r was 4. So a sub n equals a sub n minus 1 times 4. So here's a little real-life situation with a geometric sequence. You'll notice I've crossed out how it's worded. You have to be a little bit careful with where you start these things. So I'm going to say a sub 1, which is the height after the first bounce, is 4 feet. So for this one, n equals 1 and the height is 4. A sub 2, which is the second bounce, let's say this is the bounce number. So after the second bounce, it's 80%, so that's 4 feet times 0.80, which is 3.2 feet. After the third bounce, a sub 3, we have 4 feet times 0.80 times 0.80 again, which is 2.56 feet, etc. So you see how the formula works. So a sub n for any term is the first term, 4, times r, which in this case is 0.80, raised to the n minus 1. The recursive formula a sub n is going to be a sub n minus 1 multiplied by r, which is 0.80.
Like I could even give you like the chapter test I did this year in Honors Algebra 2. Okay. I'll get you that ASAP.
If we want to find out how high the ball is after the fifth bounce, we're going to take the explicit formula here and put 5 in place of n. So a sub 5 equals 4 times 0.80 raised to the 5 minus 1, or 4. And that turns out to be 1.64. So the height after the fifth bounce is 1.64 feet.